classes we are discussing about that what is the circuit and what is the network, circuit and what is here and what is the KCL, and how we are applying the KVL and KCL to do analysis for the circuit configurations, and all these things we are discussed in the previous. So now the unit number 3 is the electrical machines. Am I audible to you?
Yes, sir.
Is my voice is clear?
Yes, sir.
Yes, sir.
Hello. Hello.
Yes, sir. It's clear, sir.
Is my voice is clear? Oh, wait for 1 minute, please. One minute. I forget to add. Hello. Hello. Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
So in this unit, we want to be discuss about that what are unit. You are in the unit number 3 now, but electrical machines. So what is the importance of the electrical machines, and what are the important things in the electrical machines, and what that, and what is the construction, and what is what are the different problems you are have that we want to discuss in here. So what is the importance of the electrical machines? So what is the importance of the electrical machine? Suppose I want to be generate a power. So nowadays, if you want to do any work, what type of the work you want to be say, like either it is agriculture, either it is office, either it is IT industry, either it is educational institutions, whatever the thing, hospitals, and whatever the thing is, but we cannot imagine our life, and our life is not moving forward. Am I right? So our life is not moving forward. It's not assume our life electricity. So this is a very hot summer. So in this hot summer, we are, suppose power is went for just 10 minutes. So we are not able to withstand that 10 minutes also. So due to this hot summer, and we are feeling very flexibility with the electricity. So that much of importance is there in each and every part of our life. So without the electricity, we cannot do anything in our life. So the importance of the electricity. So if you want to be generate the electricity, so you want to be use the generator. You want to be use the generator. So what is the generator? Is nothing but a generator. So here we are seeing one, two diagrams. So this first one is the generator, and this is the motor, and this is the transformer. I'm showing with the cursor. Is the cursor visible to you? Hello.
Yes, sir.
Is the cursor visible to you?
Yes, sir.
Okay, right. So, so this is the generator. So what is the function of the generator, and what is the importance of the generator? So I want to be generate the power. I want to be by the with the help of the generator, I'm doing the electricity. So if I'm giving the mechanical energy input, it converts the mechanical energy into electrical energy, and it is giving the electrical energy to us. So that is the importance of the generator, which uses to generate the power. And this is the motor. So this is the motor. So if you want to be use the electrical appliances, the appliance it is maximum number of appliances are using a motor. Suppose if you want to go for the agriculture, you want to be do the watering for the fields, so you want to be use the motor. For the homes, suppose if you want to use the fan, you want to use the motor in that. If you want to use the printer, so in that one type of motor is using. So if you want to use for mixer, one type of motor is using. So whatever the thing you want to be take, so major applications will be depends upon will uses the motor. And next, so that's why you want to be concentrate on the DC motor. And next, all are well familiar with the transformer. General, all are transformers in your area. So all of you say, all of you, when the power is when the power is not there in your home, simply you want to be you want to be see your connections and all these things. All the connections are good. You want to be concentrate on the transformer. Is there any problem is there in the transformer? You want to be so you are no well familiar with the transformer. What is the importance of the transformer? So we know that for the generation of the power, you are using as the for the usage of the electricity for different appliances. We are using that. Then what is the importance of generally away from the example, in Telangana state, we are having different. I'm talking only the thermal power plants and hydro power plants. So we are having Kottagudem thermal power plant, and we are having a hydro plants like Sealeru and Sri Shailam, and these are all are the different power plants we are having in your areas. So that see generally for each and every whatever the town and whatever the village, whatever the area it is, we require the electricity. But we see the generating stations at in every place. Suppose if you want to go for so we are having, if you are taking an example, having any generating station nearer to Hyderabad or whatever it is. So some of the places is having generating stations and some of the places is not having their generating stations. But what you want to be do, you want to be generate the power in the stations and you want to be transform the power where the power is generating stations is also not there. For that places also you want to be give the power to the consumers. So for that what you are doing, generally the power is generating at the generating stations at very forever. So what you are doing in the general way of giving the power, the general way of the giving the power to the power in the general way of doing customers, we are generating at the generating stations. Then afterwards we are to the grid. So that suppose if you are generating the power at Kottagudem thermal power station, so then we are giving that power to the Khammam grid. So from that grid, the power is distributed to the various substations, and from that substations it is connected coming to the local areas transformers. So from that it is coming to the distribution lines through the your homes. So whatever you are generating the power and then you are transmitting the power to the customer. So we are generating the power at 11 kV, 11,000, 11 kV means 11,000 volts. At 11,000 voltage level you are generating the power. If you are transmitting the power in the same way, in same voltages, it is drawback. At the same time, whatever the power you are generating at 11 kV, that 11 kV is not useful for the home appliances. It is used for the higher, very higher, bigger industries like that, but it is not useful to the home appliances and other loads. So what you want to be do for if you want to we require, suppose if you use that agriculture, it requires three phase supply. The voltage level is 14 volts. The appliance is designed like that, but your generating voltage is 11 kV. So if you want to be reduce the voltage levels to the consumers for the agriculture homes, it is 230 volts. So how we are doing this? It's nothing but with the help of DC motor. this step up or step down. So in the distribution side, so in the home appliances or big industries, we require 11 kV or 6.6 kV or 450 volts or 230 volts. So each and every appliances is having a different. For the homes, it is 230 volts. For the agriculture, it is 415 volts. For industries, it is 3.3 kV or 6.6 kV or 11 kV, depending upon equipments. So it is for the distributor is for the consumers same equal voltage levels. Different consumers are there. They require different levels. At the same, the power is generating at 11 kV. If you are transmitting the power at the 11 kV, the efficiency of the transmission system is very low at that lower voltage. But sir, 11 kV is lower. Why you are saying lower? Higher, sir. 11 kV means you are getting very severe. It is 11 kV is low. The 11 kV is low for the transmission. If you want to be transmit the power, it requires nearly 132 kV. Minimum it is 132 kV. You want to be transfer the power in the 11 kV is not giving efficient results. If you are transmitting the power at 132 efficiency, power transmission efficiency will be 90% above. So the step up or step down, the voltage levels is done by the transformer. Is done by the transformer. So when the transformer, even though you are generating the power, even though you are of motors and generators, but we cannot imagine our power transmission levels. So the transformers, these transformers are you giving a more flexibility to utilize the power, more flexibility to utilize the power. So with the help of this transformer only with the help of this transformer only you are utilizing the power in a flexible way. So that is the major importance before transformer and after transformer. In the, you can say before Christ, after Christ. Say like that in the what? So we can say before Christ and after Christ. So here also we are saying that in the electricity we can say that we can say before transformer and after transformer. Before 1 minute, please. Before transformer and after transformer. Before transformer is 1 minute. 1 minute. So that is the importance of the transformer. With a lot of changes is there. Is my voice is audible? Hello.
Yes, sir.
Hello. Hello. Is my voice is audible?
Yes, sir.
Okay, right. So this is the thing we can say that with before transformer, one type of the power utilization is there. After the invention of the transformer, you are there. We are creating lot of wonders in the electricity utilization or transmission or distribution or generation. Whatever the thing it is, transformer is plays an important role in the generation, transmission, and distribution. In the general, the power systems electric divided into generation, transmission, and generation, transmission, and distribution. So in each and plays an important role. It plays an important role in these things. So we discuss about that generator and motor. What we are going with the transformer. So is equal to see the question on the desktop? Hello. Hello.
Yes, sir.
You can enable sorry
Yes,
on
sir.
the desktop on the screen.
Yes, sir.
So what are
Yes,
the
sir.
basic requirements for a human being? Tell me what are the basic requirements of a human being?
Sir, food, water,
Water,
food,
food,
Clothes.
Shelter.
clothes. Very good.
Shelters.
So we know that so human being is food, clothes, shelter. We know that. But in the now the modern world, the electricity is also coming into the basic requirements of a human. So in the previous days, in the olden days, we are saying that what are the basic requirements for the human being? We can say that these are three things: food, clothes, and shelter. But nowadays, you want to be see the fourth one is coming into the picture. That is nothing but electricity. Electricity is also now one of the basic requirements for the human being. So we can say that. So from where we are getting the electricity? So you generally we are not the person who is not knowing about that generation, distribution, and transmission. Say that the power is coming from the transformer. You are getting a power from our home from the transformer, which is available at our street, and we are saying that. So okay, your question is right. You are knowing about that surroundings only. Say that the for your home the power is coming from the transformer. For the transformer, where from where you are getting the transformer supply is nothing but from the substation. We can say that substation nunchi vastundi. You are saying that from the substation. For the substation you are getting the power from the generating stations, that power stations, that you are saying that power stations. So in the power station is going on is nothing but generators. In the you can call it as generating stations. So for the generating stations or power stations, you are generating the electrical energy with the help of the generator. Generator. So we know that according to the law of conservation of energy, we cannot create the energy, we cannot destroy the energy. We cannot create the energy, we cannot destroy the energy. Am I right? Hello?
yes, sir. Yes, sir.
You know the law of conservation of energy rule. We know that we cannot create the energy, we cannot destroy the energy. Am I right?
Yes, sir.
Am I right? Yes or no? Hello?
Yes, sir.
So, so from this, I want to be say simply, we want to generate the power. We want to be generate the power means we want to be use the available resources. We want to be you are available resources in your surroundings. From that you have to be you want to be electricity with the help of that resources. Take an example. Thermal power stations. thermal power stations. So for the thermal power stations, so what are the resources thermal power station? So what are the resources for station? Thermal power station resources are the coal, water, air. Coal, water. So why you are taking that resources as coal, water, and air? So what you are doing here, simply, if you want to be generate the electricity with the help of the generator, what you want to be do? See here, ma. See here. So this is the generator. They are saying this is the generator. So generator is connected to this, like a rod. This you can call it as in the electrical language. This is a shaft. So on the same, the generator is connected. For the same shaft, you are connecting some turbine. So it is inside. It is inside. So what is the purpose of the turbine? Is nothing but if you want to be, if you want electrical energy with the help of the generator will takes as an input as mechanical energy. Mechanical energy. Generator takes the mechanical energy and it is giving the electrical energy. Sir, how we are doing that mechanical energy, sir? How we are doing that mechanical energy? How we are doing that mechanical energy simply? So I'm saying that. So this generator and the generator is connected to the shaft, and the same shaft you are connecting to the turbine. So you know that turbine, like turbine, with the best example for the turbine is nothing but windmills. Windmills are there now. So say windmills. So you are having some rounding one, and after you are having a like fan arrangement. So the same fan type arrangement is so available in the turbines. So what happened? This turbine shaft. So what are the shaft is there? That shaft you are placing like this turbine. This fan laga untunna. So when నువ్వు ఎప్పుడైతే ఎలక్ట్రిసిటీ జనరేట్ చేయాలో ఈ షాఫ్ట్ ఏదైతే షాఫ్ట్ జనరేట్ కనెక్ట్ అయ్యిందో దిస్ షాఫ్ట్ యూ వాంట్ టు బి రొటేట్ ద షాఫ్ట్ then automatically the electricity will be generated with the help of available structure in the generator. Am I clear? If you are able to rotate this, if you are able to rotate, if you are able to rotate this shaft, able to rotate this shaft with the what is the available of arrangement in the generator, that will generate the power. That will generate the power. So what you want to be do? If you want to be rotate this turbine blades, ఎప్పుడైతే you can able to rotate this turbine blade, automatically the shaft is rotated, which is placed on the shaft. Okay, so I want to be rotate, I want to be rotate the turbine blades. So if you are able to rotate the turbine blades, means rotation is nothing mechanical energy. So if you are able to rotate, you are giving the mechanical energy as the input to the generator. It's convert into a electricity. So for that, if I want to be rotate that, what you are doing with the help of these available resources. So I want to be, I'm using the what are the resources? Water, coal, and air. So what I am doing, what I'm doing here, nothing. I'm converting a water into a steam. I'm converting a water into a steam. What I'm doing, I'm converting water into a steam. Sir, what happen if you are converting water into a steam? So for the conversion, means if you want to be convert the water into a steam, what you want to require? You want to be heat the water. So heating, I'm burning the coal in the presence of air. I'm burning the coal in the presence of the air. So then what happens? Water is converted into a steam. Sir, what happens, sir, if you are converting water into a steam? But the steam is having high pressure. The steam is having the steam is, if you are increasing the steam temperature, automatically the pressure is also increased. Yes. Hello, is it?
Yes, sir.
Yes, right. So if you steam pressure, how we are increasing the steam pressure? You want to be give the more energy. So what you are doing here, what you are doing here, you are increasing the steam pressure. Then that steam, high pressure steam is released on the turbine blades. Is released on the turbine blades. Then what? Automatically turbine blades want to be rotate or not? Rotate.
Yes, sir.
Hello, Nana.
Rotate.
Hello.
Sir,
Yes.
rotate అవుతాయి sir.
Yes. turbine blades rotate out. So what happens when the turbine blades are rotated? It is acting as that is given to the input to the generator according to the construction which is having in the generator. The electricity is made. So what is the input for the generator? Generator is taking the input as a mechanical energy and it is converting into a electrical energy. A generator converts this is the generator. So you are giving the mechanical energy as the input and it is converting into a electrical energy. So that is the thing. So if you want to be generate the electric, you want to rate induced EMF. That is nothing but simple. Induced EMF. You want to be induced the power is generated. So if your induced EMF is generated, that is collected toward, then collected to the load means what happened? Current collected to the load. When it is connecting to the load, what happened? Flow of electrons will be going on. Then automatically this total work done, you are calling it as a power. So that total energy is the electrical energy. So what is the basic requirements for the generation of electrical energy? So before going to the working principle of the generator. What is the working principle of the generator? What is the working principle of the generator? Is nothing but the Faraday's laws of electromagnetic induction. Faraday's laws, it is working on the Faraday's laws. It is working on the Faraday's laws. Whenever conductor cuts the magnetic field, whenever a conductor cuts the, an EMF will be induced in the conductor. An EMF is induced in the conductor. That EMF induced is want to be colored. So a flow of current will be going on. So is the electricity. Am I clear? Hello? Is the law is clear? It is not having any proofs and all these things. If it is having a proofs, that is a law, is a theorem. So law is not having a proof. A law is a law, like a gravitational law. Gravitational. So due to the gravitation, all the will be fall on the attracted towards the earth. So that is a law. Why it is going on means earth is having gravitational force అంటాం కానీ ఆ గ్రావిటేషనల్ ఫోర్స్ ఎంత ఉంది ఎంత బట్టి లాగుతుంది ఏంటి కెనాట్ సే. సో దట్ ఈస్ ద లా. ఎందుకు వస్తుంది గ్రావిటేషనల్ ఫోర్స్ ఉంది, ఎలా ఉంది, ఎంత ఉంది, ఏముంది, వి కెనాట్ సే. సో ఇన్ ద సేమ్ whenever a conductor field an EMF will, whenever a conductor cuts the magnetic field an EMF will be induced. So in order to induce an EMF according to this law, we can say that whenever a conductor cuts the magnetic field means inside the generator you want to be generate the power, you want to means what you require is nothing but whenever a conductor, you are using a conductor to generate the, whenever a conductor cuts the magnetic field means whenever a conductor cuts the magnetic field means it requires conductor and magnetic field cuts the magnetic field. We require conductor and magnetic field. You want to be rotator or magnetic field. Only one thing you want to be rotated, either magnetic field or conductor. Means one rotation is there. We require some relative speed in between them. Yeah. Hello. Am I clear? Right. Okay. So we want to generate the power. We require what? We require a conductor and we require a magnetic field. So with relative speed in between them in order to generate. Okay. So conductor, magnetic field, and relative speed. So these are the major parts of an DC generator. DC generator. So this is the cross-sectional view of the DC generator. This is the cross-sectional view. This is the cross-sectional view of the DC generator. So this is the yoke. This is the outer frame. This is the yoke. You are able to see. This is the yoke. You can able to see my cursor. This is the yoke. Hello, ma.
Yes, sir. It's visible.
Yes, this is the yoke. So first I'm telling the parts, and afterwards I will tell what are the function of each and every part. Okay. So this is the yoke, and next this is the pole. This is the pole, and this is the pole core. This is the pole, and this is the pole shoe. This is the pole. This total is the pole. Okay, this total one is the pole. This pole is having a two parts. So this is the pole core shoe. This is the pole core, and this is shoe. Okay. Next things. This windings is the pole windings. Some black color lines. So this thing is a field windings, a field coils. This is the pole. Okay, so it is a pole core and it is a pole shoe, and this black color lines are the field windings or field coils. Am I clear? Field windings are field coils. Then so this is the armature core. This is the armature core. And what are the winding is present in the armature? That is the armature winding. That is the arm. Am I clear? Winding. And next, commutator. Where the commutator? So this is the commutator. The commutator. And these are the brushes. Inside the brushes we are having some bearings. This is the cross-sectional view of the generator. So once if you see the cross-sectional view, so what are the major parts? Yoke is having a two parts, pole core and pole core. So on the pole you are placing the windings. That winding field windings are field coils. So in the center we are having the armature, and that you are having a armature core. Center we are having the armature core. What are the windings you are placing on the armature? That is armature winding. And next we are having a commutator. It is in between armature and the brushes, and brushes and brush holders are there, and bearings is for the rotation. Bearings are for the smooth rotation. Am I clear up to now?
Yes, sir.
Hello. Any doubts ma up to now? Any doubts up to now?
No, sir.
Okay. So next. So ఇక్కడ చూపిస్తాను చూడండి parts. Hook. So this is the hook to hang it or to pull it. Sorry, to hold it. Pole, field winding, armature, commute, rotation. So clear, yoke, field winding, pole, armature, commutator. Is it clear? Ma, is it clear? The parts is clear?
Yes, sir.
So I'm saying that how it is converting. So what is the working is going on here? Are the field magnetic field. So if you want to be create the magnetic field, we are not using a permanent magnets here. Magnet and simply we can remember that permanent magnets. But we are not using the permanent magnets here. We are using the electromagnets. We are using the electromagnets. So if you want to be generate the power, how much of power you want to be generate depending upon you are giving the field. So for that we are using that electromagnets. So if you are taking a permanent magnets means we cannot change the magnetic field effect. If you are lesser or if you want to be higher, we cannot change it. Suppose if you are using electromagnets, you know that whenever a conductor through the electricity, a magnetic field. If you want to increase the magnetic field effect, you want to improve the supply. If you want to decrease the magnetic field effect, you want to be decrease the supply. So you are giving the DC supply. What is the purpose you are giving the DC supply means? If you are giving the DC supply, the strength of the magnetic field will be longer and uniform magnetic flux is. Am I clear? Hello? Hello?
Yes, sir.
Hello, is it clear to all of you? Is it clear?
Explain one again, sir.
Anna? Your
Repeat
voice
once.
is not clear.
Sir, repeat once again, sir.
Your voice is not audible. Keep a message. I'm unable to hear your voice. Please keep a message.
Sir, repeat once again, sir.
Repeat once again. Okay, right. So according to law చెప్పాను కదా ఒక లా బేస్ చేసుకొని జనరేటర్ వర్క్ అవుతుంది అని చెప్తాను. సో ఫర్ దట్ లా వాట్ యూ రిక్వైర్, we require one conductor and we require whenever a conductor cuts the magnetic field, we require a magnetic field. So for that magnetic field, so generally we know about that magnetic field. Simply we are generally remember that permanent magnets. Okay. So permanent magnets, if you are taken that permanent magnets means once the magnet is fixed inside the machine, we cannot change the magnetic field effect. Suppose magnetic field we cannot change. If you require magnetic field, we cannot change. Once it is inserted, it is fixed. We cannot do anything further. So for that you are using a electromagnets. So why how the magnetism is going on? When you know that when simply you are taking a conductor and if you are flowing that current through that conductor, magnetic field will be generated. You know that. So that is will be you are studying in a 8th standard or 9th standard. You are knowing about that electromagnets. Whenever a conductor brings some electrical energy, magnetic field is created around the conductor. So by using that law, you are using electromagnets. So for that, you are to place a windings. అంటే నీకు ఇక్కడ ఏం కావాలి, కండక్టర్ లో కరెంట్ ఫ్లో చేయాలి. ఆ కండక్టర్ ని ప్లేస్ చేయడానికి, మ్యాగ్నెటిక్ ఫీల్డ్ క్రియేట్ చేయడానికి మనం ఏం చేస్తామంటే ఇలా ఒక అరేంజ్మెంట్ తీసుకున్నాం. ఇక్కడ ఉంది కదా, దిస్ అరేంజ్మెంట్ యు ఆర్ కాలింగ్ ఇట్ యాజ్ అ పోల్. ఈ పోల్ అనే అరేంజ్మెంట్ తీసుకొని దీన్ని యోక్ కి ఫిక్స్ చేస్తారు. దిస్ ఈస్ కనెక్టెడ్ టు ద యోక్ అండ్ ఆన్ దట్ on that pole you are placing a windings like this. ఇలా windings place ఇక్కడ ఉన్నాయి చూడండి windings. సో ఇవి ఇలా windings place చేస్తాం. ఓకేనా, దిస్ ఇస్ ద పోల్స్. ఆన్ ద పోల్స్ placing a winding. ఓకే, సో ఇలా 1 2 3 4 మన డిపెండింగ్ అపాన్ అవర్ మ్యాగ్నెటిక్ ఫీల్డ్ డెన్సిటీ, నాకు ఎంత మ్యాగ్నెటిక్ ఫీల్డ్ కావాలి దాన్ని బట్టి మనం పోల్స్ డిసైడ్ చేస్తారు. సో ఆన్ దట్ యు ఆర్ కనెక్టింగ్ ద వైండింగ్స్. సో ఇవన్నీ చూడండి ఇలా కనెక్ట్ అయ్యి ఉన్నాయి. ఇలా లాస్ట్ కి 2 టెర్మినల్స్ వస్తున్నాయి చూడండి, అన్నిటి నుంచి 2 టెర్మినల్స్ వస్తాయి. సో ఈ 2 టెర్మినల్స్ కి మనం 2 టెర్మినల్స్ కి ఏమి ఇస్తారు నాన్న, డిసి సప్లై ఇస్తాం. సో డిసి సప్లై ఇస్తే అక్కడ డిసి ఎక్సైటేషన్ ద్వారా డిసి మ్యాగ్నెటిక్ ఫీల్డ్ క్రియేట్ అవుతుంది. సో వై ఆర్ టేకన్ డిసి సప్లై నాట్ ఏసీ అంటే డిసికి వచ్చేసరికి స్ట్రైట్ లైన్, ఏసీకి వచ్చేసరికి ఆల్టర్నేటింగ్ లైన్ అని చెప్తాం. సో ఆల్టర్నేటివ్ ఇస్తాం. ఆల్టర్నేటింగ్ లైన్ లో ఏమవుతుంది అంటే యూనిఫామ్ మ్యాగ్నెటిక్ ఫీల్డ్ క్రియేట్ అవుతుంది ఏసీ ఇస్తే. అదే డిసి ఇస్తే ఏమవుతుంది అంటే స్ట్రెంగ్తెడ్ మ్యాగ్నెటిక్ ఫీల్డ్ జనరేట్ అవుతుంది. సో For reason you are giving the DC supply to the coils, then automatically magnetic field is created. Am I clear up to now? Hello? Hello? Yes? Is it clear? Hello?
Yes.
Right. Then after, so magnetic field is present. Then after, what you want to be require? We require a conductor. We require a conductor. So where you want to be place the conductor? What you are saying? The conductor cuts the magnetic field. Means you want to be place the conductor in the presence of magnetic field. You want to be place a conductor in the presence of magnetic field. Am I clear? So if you want to be cut the conductor, the magnetic field cuts by the conductor means you want to be placed in the presence of magnetic field. So what I am doing here, I am placing a field coils, means these we are calling it as a field antam. Fielding antam. ఇదంతా కూడా field winding, field అంటాం here. సో దీన్ని మొత్తం దిస్ టోటల్ అరేంజ్మెంట్ ఏదైతే ఫీల్డ్ కానీ ఫీల్డ్ క్రియేట్ చేసావో, ఫీల్డ్ కాయిల్స్ పెట్టావో, డిసి మ్యాగ్నెటిక్ అంటే ఎలక్ట్రోమాగ్నెట్స్ ఏవైతే క్రియేట్ చేసావో, సో దిస్ ఆర్ కాలింగ్ ఇట్ as a stator. Why you are calling it as a stator means it is a stationary one. ఈ మ్యాగ్నెట్ ఏం రొటేట్ చెయ్యం నా, ఇది స్టేషనరీగా ఉంటుంది. సో దట్స్ వై ఆర్ కాలింగ్ ఇట్ as a stator. సో అప్ టు నౌ ఇట్ is clear. Want to be place a conductor in the presence of magnetic field. ఏం చేస్తామంటే ఇది ఒక సిలిండ్రికల్ షేప్ లో ఉంటుంది నాన్న, ఇట్లా ఉంటుంది. మీకు ఇక్కడ క్రాస్ సెక్షనల్ వ్యూ చూపిస్తున్నారు కానీ ఒక సిలిండ్రికల్ షేప్ లో ఉంటుంది. నేను మీకు తర్వాత చూపిస్తాను. సో ఇలా నీకు షేప్ తీసుకుంటాడు. ఆర్మేచర్ అంటాం దీన్ని, ఇది ఆర్మేచర్ అంటాం. ఇలా బ్లేడ్స్ లాగా కనిపిస్తుంది కదా, ఎల్లో డాట్స్ కాకుండా బ్లేడ్స్ లాగా వైట్ కలర్ లో కనిపిస్తుంది కదా. సో దీని అంతా మనం ఆర్మేచర్ అంటాం. ఈ ఆర్మేచర్ లో ఇక్కడ వైండింగ్స్ కండక్టర్స్ అని ఆర్మేచర్ మీద ప్లేస్ చేస్తాం. ఆర్మేచర్ మీద వైండింగ్స్ ప్లేస్, కండక్టర్స్ ప్లేస్ చేస్తాం. సో ప్లేస్ చేయాలి వెన్ ఎవర్ ఏ కండక్టర్ కట్స్ ద మ్యాగ్నెటిక్ ఫీల్డ్. అంటే ఫీల్డ్ అన్న చేంజ్, ఇక్కడ మనం ఏ ఫీల్డ్ క్రియేట్ చేసాం? యూనిఫామ్ ఫీల్డ్ క్రియేట్ చేసాం. చేంజ్ ఇన్ ఫీల్డ్ ఉండాలి, లేదా ఇక్కడ ఏమై ఉండాలంటే కండక్టర్ నైనా రొటేట్ చేయగలగాలి. చేంజ్ ఇన్ మ్యాగ్నెటిక్ ఫీల్డ్ మనం ఇవ్వట్లేదు, ఎందుకంటే మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రాంగ్ గా ఉండాలని చెప్పేసి మనం డిసి ఇచ్చేసి యూనిఫామ్ ఫీల్డ్ క్రియేట్ చేసాం. చేంజ్ ఇన్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇవ్వాలి. సో ఇంకా కండక్టర్ మ్యాగ్నెటిక్ ఫీల్డ్ కట్ అవ్వాలి అంటే కండక్టర్ ని రొటేట్ చేయాలి. సో ఈ రొటేట్ చేయడం కోసం ఏం చేస్తామంటే, ఇక్కడ రొటేట్ చేయడం కోసం ఈ ఆర్మేచర్ ఉంది కదా, ఈ ఆర్మేచర్ నువ్వు షాఫ్ట్ మీద పెట్టి సేమ్ షాఫ్ట్ కి టర్బైన్ ని కనెక్ట్ చేస్తావు. సో టర్బైన్ ఎప్పుడైతే స్టీమ్ రిలీజ్ చేయడం ద్వారా టర్బైన్ రొటేట్ అవుతుందో, ఆటోమేటికల్ గా ఆ షాఫ్ట్ మీద కనెక్ట్ అయి ఉన్న ఈ ఆర్మేచర్ కూడా రొటేట్ అవుతుంది. దీన్ని రోటార్ అంటాం. యు ఆర్ కాలింగ్ ఇట్ as a rotor. Why it is a rotating one. So the same shaft is connected to the rotor, then automatically this rotor rotating, then automatically what are the conductors placed on the armature is also rotating. Then the magnetic field is cutted, then automatically EMF will be induced. Student, so if you are connecting these to these poles, then what happens? So magnetic field అనేది, magnetic flux అనేది అదా ఫ్లో అవుతూ ఉంటుంది. నార్త్ పోల్ టు సౌత్ పోల్ ఇలా. సో నార్త్ పోల్ టు సౌత్ ఇలా, నార్త్ పోల్ టు సౌత్ పోల్, నార్త్ పోల్ టు సౌత్ పోల్. ఇక్కడ యోక్, what is the yoke is there? So that yoke is the magnetic field transforming area. magnetic field ఏదైతే ఉందో అది దీని నుంచి ట్రాన్స్ఫర్ అవుతూ ఉంటుంది from north pole to south pole. Am I clear? magnetic flux lines అనేవి ఇలా ఫ్లో అవుతాయి. ఓకే, సో magnetic flux lines ఫ్లో అయిన తర్వాత మనం ఏం చేస్తున్నాం? యు ఆర్ రొటేటింగ్ ద రోటర్. సో ఎప్పుడైతే ఆ షాఫ్ట్ టర్బైన్ రొటేట్ అయిందో, ఈ రోటర్ కూడా రొటేట్ అవుతూ ఉంటుంది. సో ఎప్పుడైతే ఈ రోటర్ రొటేట్ అయిన కనుక లోడ్ కనెక్ట్ చేస్తే, ఆ లోడ్ కి కరెంట్ ఫ్లో అయ్యి పవర్ అనేది అది జనరేషన్. హలో మా, ఇస్ ఇట్ క్లియర్?
Yes, sir. Yes, sir.
సో ఇది దీని వర్కింగ్ ఎలా వర్క్ అవుతుంది. ఇది జనరేటర్ ఎలా వర్క్ అవుతుంది? You are giving the magnetic field supply, then magnetic field lines is created whenever the conductor is armature is rotated, automatically EMF will be induced. So that EMF you are connected to the load, then automatically the power will be the load will be working. This you are calling it as a generation of electrical energy. Am I clear up to now?
Sorry.
Yes. So, sir, electrical machine అన్నారు కదా. సో మెషిన్ ఈస్ నథింగ్ బట్ సింప్లీ జనరేటర్ మోటార్ రెండు మెషిన్ అయినా ఒకటే మెషిన్. జనరేటర్ కానీ మోటార్ కానీ కన్స్ట్రక్షన్ వైజ్ దెర్ ఇస్ నో డిఫరెన్స్. ఇఫ్ యు ఆర్ గివింగ్ వాట్ ఎవర్ ద ఇన్పుట్ యు ఆర్ గివింగ్ a input as a electrical energy, it gives mechanical energy as output. If you are giving a mechanical electrical energy output, సో నువ్వు ఎలక్ట్రికల్ ఎనర్జీ ఇన్పుట్ ఇచ్చావు, అది మెకానికల్ అవుట్పుట్ ఇస్తుందంటే అది మోటార్. ఇఫ్ యు ఆర్ గివింగ్ a మెకానికల్ ఎనర్జీ ఇన్పుట్, అది ఎలక్ట్రిసిటీ ఇస్తుంది అంటే అది జనరేటర్. అంటే మెషిన్ అంటాం. అందుకే కామన్ లాంగ్వేజ్ లో జనరేటర్ ని కానీ మోటార్ ని కానీ మెషిన్ అంటాం. దట్ మెషిన్ కన్స్ట్రక్షనల్ వైజ్ జనరేటర్ కి మోటార్ కి డిఫరెన్స్ ఉంటుంది. అదొక మెషిన్. ఆ మెషిన్ కి నువ్వు ఇన్పుట్ ఎలక్ట్రిసిటీ ఇస్తే మెకానికల్ ఎనర్జీ అవుట్పుట్ వస్తుంది, అప్పుడు అది మోటార్ కింద యాక్ట్ అవుతుంది. అదే మెకానికల్ ఎనర్జీ ఇన్పుట్ ఇస్తే ఎలక్ట్రికల్ ఎనర్జీ అవుట్పుట్ వస్తుంది, అప్పుడు జనరేటర్ కింద యాక్ట్ అవుతుంది. ఉంటుంది నాన్న ప్రాక్టికల్ గా. యోక్ ఇలా ఉంటుంది. ఇది యోక్, ఇది యోక్. సో దిస్ ఇస్ అ యోక్. సో ఈ యోక్ లో ఇది టెర్మినల్ బాక్స్. మనం డీసీ సప్లై ఇవ్వాలి కదా ఫీల్డ్. సో ఆ ఫీల్డ్ 2 వైల్స్ వెళ్ళాలి కదా బయటికి. సో ఈ టెర్మినల్ బాక్స్ నుంచి వస్తుంది. సో అది టెర్మినల్ బాక్స్. ఇది లిఫ్ట్ చేయడానికి. ఇది ఫ్రేమ్, యోక్ యొక్క ఫ్రేమ్. ఇవి ఫీడ్స్ అంటే బేస్ కింద యూజ్ అవుతాయి. వాట్ ఈస్ ద పర్పస్ ఆఫ్ ద యోక్? ఇస్ నథింగ్ బట్ ఇట్ ఈస్ ద outermost frame. It is giving a mechanical support to the generator గాని, అండ్ ఈ పోల్స్ కి మెకానికల్ సపోర్ట్. ఈ ప్లేసింగ్ ఈ యోక్ మీదనే కదా మనం ఇక్కడ పోల్స్ పెట్టింది. ఇట్ ఈస్ గివింగ్ అ మెకానికల్ సపోర్ట్ టు ద పోల్స్ ఆల్సో, అండ్ ఇట్ ఈస్ మేడ్ అప్ ఆఫ్ క్యాస్ట్ ఐరన్. సో నేను ఇంతకుముందు చూపించిన డయాగ్రామ్ లో మ్యాగ్నెటిక్ ఫ్లక్స్ లైన్స్ నార్త్ పోల్ నుంచి సౌత్ పోల్ ఇలా ఫ్లో అవుతూ ఉన్నాయి. అంటే మ్యాగ్నెటిక్ లైన్స్ అనేవి యోక్ లో ఫ్లో అవ్వాలి అంటే దానికి లో రిలక్టెన్స్ పాత్ ఉండాలి. వాట్ ఈస్ మెant బై రిలక్టెన్స్? అపోజిషన్ మ్యాగ్నెటిక్ ఫీల్డ్ అపోజిషన్ ఎక్కువ ఉంది అనుకోండి, మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ రాదు. కాబట్టి ఏదైతే మెటీరియల్ తీసుకున్నావో దట్ మెటీరియల్ షుడ్ బి లో రిలక్టెన్స్ పాత్. సో దట్ మెటీరియల్ ఈస్ కాస్ట్ ఐరన్. It is made up of cast iron. So it is giving a low rate of magnetic field. So north pole to south pole yoke nunche kada students the previously. So yoke lone kada ee white lines anni ekkada blink avutunayi? These white lines are all blinkered here. So north pole nunchi south pole, north pole nunchi south pole, north pole nunchi south pole magnetic field avutu undali. So ante low reluctance path undali. Adi yoke. This is the function of the yoke. సో స్మాల్ మెషిన్స్ కి యోక్ ఇలా ఉంటారు నాన్న. ఇది యోక్. ఇవి పోల్స్ అన్నాం కదా, ఆ పోల్స్ ని ఫిక్స్డ్ కాయిల్స్ అంటారు. సో దిస్ ఇస్ ద యోక్. స్మాల్ మెషిన్స్ కి యోక్ అలా ఉంటారు. సో నెక్స్ట్ దిస్ ఇస్ ద పోల్. ఐఎమ్ సేయింగ్ ద 2-1 పోల్ కోర్ అండ్ పోల్ షూ. సో ఇక్కడ చూడండి అన్ని లైన్స్ లాగా ఉంది కదా. See here all our lines is there na. Hello.
Yes sir.
So this is in the lines shape. Lines అంటే if you have taken window తీసుకుంటే అదండి ఒక వుడెన్ పీస్. విండో కానీ డోర్ కానీ తీసుకుంటే అదొక వుడెన్ పీస్. టోటల్ 1 వుడెన్ పీస్ ఉంది. బట్ హియర్ pole is having suppose 10 centimeters length unna pole kavali. If you require the 10 centimeters length of width of pole, so we are not taken 10 centimeters at a time. You are not taken. What you are doing, you are taken some small width 0.2 centimeters thickness. 0.2 centimeters thickness. Sir,
బ్రేక్ ఇద్దామా సార్? మీరు అయిపోతే
ఒక్క 2 minutes సార్.
Okay, sir.
Just 2 minutes. So 0.2 centimeters thickness, 0.2 centimeters thickness of sheet is taken. So if you require some 10 centimeters, how many you require? Around you require 100. You require 100. So 0.2 centimeters. If you want to be make it as a 10 centimeters means we require 0.2 centimeters individually, 200 pieces. All are sandwiched together 10 centimeters. Here also we are not using a single field and all are sandwiched to get 0.2 centimeters width. So that all are sandwiched together to form a pole. So in this way you are taking that lines and all are fitted with a bolt, rivet bolts. బోల్స్ నుంచి ఫిట్ చేసి దానికి యోకి కట్టేస్తాం. సో ఇక్కడ ఎయిర్ డక్ట్స్ ఉంటాయి, హోల్స్ ఉంటాయి, ఎందుకంటే ఎయిర్ ఫ్లో అవుతూ ఉండడం. ఇది పోల్ షూ, ఇది పోల్ షూ. సో ఇక్కడ పోల్ షూ ఎందుకు ఉంది? సీ హియర్. సో పోల్ ఇలా ఎందుకు స్ట్రైట్ గా ఇలా ఎందుకు పెట్టలే? ఇలా స్ట్రైట్ గా ఎందుకు పెట్టలే? పోల్ షూ ఇలా అంటే యూనిఫామ్ గా అన్ని కండక్టర్స్ లో కట్ అవ్వడం కోసం. ఇక్కడ ఇలానే ఉందనుకోండి, ఇలా ఉంటే మొత్తం అన్ని ఇక్కడ వరకు కట్ అవుతుంది. సో ఇట్ ఈస్ నాట్ లైక్ దిస్. సో అందుకని ఇలా పెడతాడు అన్నమాట. సో ఇలా పెడితే ఇలా పెడితే ఏమవుతుంది? పోల్ షూ ఇలా ఉంటే ఏమవుతుంది అంటే యూనిఫామ్ మ్యాగ్నెటిక్ ఫీల్డ్ కట్ అవుతుంది. అది పోల్ షూ. సో ఈ పోల్ షూ అంట. సో దిస్ ఇస్ పోల్ ఇస్ ఆల్సో మేడ్ అప్ ఆఫ్ క్యాస్ట్ ఐరన్. సో ఇది పోల్ షూ ఇలా ఉంటుంది చూడండి, ఇలా ఉంది పోల్ షూ. ఇది పోల్ షూ. So this remaining things we will discuss in the next class. Okay. Hello.
Sir. I'll claim my house. Sir. You can leave,
Okay.
sir. Okay, thank you.
Sir.
Mechanical students. Am I audible?
Yes, sir.
Yes, sir.
Listen, please. Today's work is drawing. I'll assign today's drawing work to you people. Anyone keep at least 4 to 5 sums. 4 sums పెట్టమన్నా ఒకసారి ఎవరైనా. Anyone keep 4 sums. Anyone keep 4 sums to me? Yeah. Then మా HPP మేడం అవర్ తీసుకున్నాను నేను. ఇప్పుడు లాస్ట్ అవర్ ఫ్రీ అవర్ ఉండకపోవచ్చు, ఇప్పుడే నేను తీసేసుకున్నాను. I'll be you can log in at 1. ఏమో అర్థమవుతుందా?
Yes, sir.
హలో,
Sir.
రెస్పాండ్ అవ్వండి. ఫ్రీ అవర్ ఇస్తున్నా మీకు నేను. You can leave right now. Log in at 1:40 sharp for draw. Can I end the meeting? Be ready for drawing observations. 1:40 log in అవ్వాలి. Can I end the